This year's biggest cold joke: programmers created artificial intelligence, only to be the first ones put out of work by it. This quip has been making the rounds everywhere, from market stall aunties and keyboard warriors to journalists, entrepreneurs, and even industry bigwigs, especially CEOs peddling AI solutions. On YouTube and other social platforms, tech vloggers churn out videos daily. One moment boasting how some large language model outshines humans in coding tests, the next claiming some tool has taken over the entire job of a full stack developer. It's a constant hype fest. To test these claims myself, I dove in and used AI to build a few small projects, experiencing firsthand the so-called dread of unemployment. Let me walk you through what I found. Project: a flashy start, some hiccups, and a smooth finish. My first project was a photo facial detection system with recognition, retrieval, and digital OCR. I has a flashy start, some hiccups, and a smooth finish. To get a well-rounded take, I asked ChatGPT, Gok, Gemini, and DeepSeek for recommendations. All of them suggested similar approaches. Since I wanted a quick build, I went with Deepface plus FAISS for the facial recognition part. For OCR, I initially followed their advice and picked Tesseract. After settling on the plan, I threw a few lines of requirements at each AI and skimmed their generated code. Grok's output stood out. It was concise, ran with almost no tweaks, and passed the single photo test. Over a few rounds, I had it add command, line argument handling, and batch photo processing. There were minor hiccups, but overall, it was a breeze, pleasant enough to briefly push aside any unemployment jitters. Then I hit a snag. Tesseract's performance was subpar. After some trial and error and manual testing, I switched to Pada OCR. Modifying the code for this was easy, but the AI fell flat when it came to resolving Python package compatibility issues. Deepface, FAS, Du, and Pada OCR clashed over PyTorch, TensorFlow, and CUDA versions. None of the AIs could help me navigate this mess. I had to ditch them, scour Google, forums, and docs, and cobble together an ugly workaround. I gave up on GPU support in peddling OCR and leaned on PyTorch's forward compatibility to sort out TensorFlow's version conflicts. Side note: the versioning mess with TensorFlow, Python, Du, and deep learning frameworks is still a disaster. No offense to the AI experts out there, but their programming and software engineering skills are honestly pretty abysmal. As I piled on more features, the codebase grew, and my honeymoon with AI lasted all of 90 minutes. Then the AI started spitting out infuriating, blood pressure spiking, downright maddening code. Through this chaos, I figured out some tricks for working with it. Keep tasks small and self-contained. Provide ample context, often uploading existing coding, and explicitly demand changes based on what's already there. Even so, problems persisted, and I frequently had to dig up answers or write code myself. After some stumbling, I still managed to wrap up the project. Second project done smoothly, but with crappy code. Next, I built a tool to convert Word documents into videos. Armed with my first project's lessons, I started by asking the AI for feasible approaches. Its responses were long-winded and vague, sales pitch territory, and it even tossed in some unsolicited code. I settled on this pipeline: use a pre-designed PPT template to convert the Word doc to PowerPoint, extract the PPT notes for text to speech, export the slides as images, and combine them with audio to create a video with subtitles. I broke it into modular steps and had the AI generate code for each. But when it came to matching subtitle timings with audio duration, no matter how I prompted, the AI couldn't get it right. Ended up writing a few lines myself. Meanwhile, the AI's attempt was a bloated 20th lines of nonsense. Knowing it couldn't handle newer open source tools, I swapped in F5 TTS for the speech module myself and finished the project. Third project, endless bug loops and ultimate failure. For my third project, aim to build a full backend management system for the first photo project. My quirky requirements for sessions and user authentication threw the AI off. Its code was shoddy, often broken, and needed constant fixes. Fixing one bug spawned another, which broke something else, and I got stuck in a loop. Eventually, I gave up, planning to revisit it later. To keep things manageable, I stuck with Python, like the first project, and used Fast API as the AI suggested, even though I'm more comfortable with Java's Spring framework. Every time the AI's code flopped, I had to dive into FastIP docs to figure it out myself. In hindsight, I should have just stuck with Spring and coded it from scratch. Many developer friends have had similar experiences, though they worked within familiar languages and frameworks. Unlike my newbie perspective, the journey went from, wow, this is amazing, to, oh, what is this garbage? The big shift. Complexity skyrocketed, and so did the code volume. AI strengths and limitation. AI shines with simple, well-defined tasks, known algorithms, and functions it's been heavily trained on. Programmers can't know every domain inside out, and AI fills that gap nicely. But it's not flawless. Experts who already know the codes, often because they wrote it, don't save much time with AI. For newbies, the catch is that AI's output can look slick but be total nonsense, and they won't spot it right away. When they do, it's a slog to fix. So AI is handy here, but it's kind of a mixed bag. AI's weakness, complex demands, large-scale code bases, and intricate projects. AI falls apart without human oversight, it's useless solo. Here's where I ran into inconsistency. AI tweaks its own code randomly, same logic, but with pointless changes like added comments, reformatting, or rename variables, gumming up version control, memory loss. It forgets prior code, churning out incompatible new stuff. At its worst, fixing one bug creates another, trapping you in an endless cycle. Unpredictability. Sometimes it nails it on the first try, other time it spits out bizarre, brain-dead code. Is it bad training data or AI hallucination? Who knows? Rare use cases. For niche needs, its code is mostly junk. Hand coding is faster and saner. Generative AI leans hard on training data, and it shows big picture blindness. AI can't grasp or express how components in a large project connect. Ask it to tweak one file's logic, and it might access functions other modules rely on. A few slip-ups later, you're lost tracking what it broke. These issues bred deep distrust. I spent ages reviewing and testing its output. For poorly trained domains, its code was inefficient garbage, often needing a full rewrite at a when. 10 ratio to human written code. Sure, AI churns out code fast, but it's usually bloated and sloppy. Not all of this is AI's fault. Humans play a role too. Communication gaps. Misunderstandings happen even between people, let alone with machines. Ambiguity or piled up missteps over time lead to weird, broken code. Fixing it might mean unraveling the whole process, exhausting stuff. Back to the big question. Will AI make programmers obsolete? Short term, not a chance. AI rocks at automated testing and repetitive tasks, but it flops at grasping complex needs, innovating, or tackling unknowns. Software development isn't just coding, it's requirements analysis, system design, teamwork, and communication, all needing human creativity and judgment. Right now, AI is a limited psychic boosting efficiency, not replacing anyone long term. Still more about boosting programmers than ousting them. As it evolves, it'll likely handle more rote, standardized coding, shifting what programmers focus on. They'll need to level up, mastering high level design, architecture, innovation, and AI collaboration. Programmers will still be coders, just not grinding out repetitive, cookie cutter stuff. Here are the tips for coding with AI. Today, break big projects into small, standalone chunks. Keep the code volume per AI task low. Don't overwhelm it. Be crystal clear with requirements. Ambiguity is the enemy. When tweaking old files, upload them and explicitly say, build on this. Set coding standards up front and nudge AI to stick to them periodically. Use AI for common functions. Rare ones are better hand-coded. Never trust AI output blindly. Always review and test ask it for test code too. Back up files before swapping in AI's edits. You never know when it'll go haywire. A spicy side question. Without programmers' code, could AI learn to code itself? AI experts are chasing this dream. AI that learns to program like humans do. I've hashed this out in a past episode. My take: if AI could self-teach coding, it'd mean it could create autonomously, no humans needed. AI writes programs, programs run AI, iterates, writes better programs, rinse and repeat. Sounds thrilling, right? But I say it's impossible. To buck in the optimism of many, including big-name AI gurus. Some point to AlphaGo mastering Go through self-play, outstripping humans in a complex game. So why not coding? They're underestimating it. Go has simple rules and clear win conditions. Perfect for reinforcement learning and adversarial networks. Coding. No model or method today comes close. 10 to 20 years from now, still a no from me. It's akin to, can AI gain consciousness? Maybe tougher. Coding isn't just typing lines. It's understanding how the world works and translating that into logic, a uniquely human process. Programmers are the elite at this. People joke that any high schooler can train up and code. I say if they can, they're a genius who'd ace college too. Reb. Instead of fretting about replacement, programmers should focus on teaming up with AI and leaning into creative work. I'm bullish on programmers, so much so that I've raised all three of my kids to be coders.